Assalamu alaikum. How are you guys? Hope you are all fine. Today we will learn how to convert recurring decimal numbers as rational number. First we should learn what are the recurring decimal numbers. I will show you with this book that recurring decimal numbers are those decimal numbers with an infinitely repeating pattern of digits after the decimal point. It means that after the decimal number, I will give you an example that if we have 0.3, 3, 3 and so on, there is a digit 3 after the decimal place which is repeating. So this kind of decimal numbers in which one digit, two digits or more than two digits are repeating, those decimal numbers are called recurring decimal numbers. Like here 0.333 and so on. Here 3 is repeating, so we can write it as 0.3. We will mention a bar on the number which is repeating. Here we can write it as 0.6. We will show the bar on the digit 6, which indicate that 6 is repeating, not 1. Bar is on 6. Now if we have more than 1 digits which are repeating in a pattern, so we will show the bar on the more than 1 digits. Number of digits which are repeating, which are showing pattern, we will show the bar on them. Now the purpose of our today's video is the question of exercise 1.1 of new book of session 2 2025 of class 9. Question number 3. Express the following as rational number p over q where p and q are integers. Here are the three recurring decimal numbers which we are going to convert them as rational numbers. Question number 3. Exercise 1.1, first part 0.4. First of all, we will suppose this number as an unknown variable as x. Now we can write that 0.4 bar as 0.444 because the bar indicating that 4 is repeating. We will write it as an expression 1. Now we will multiply it with the 10, multiplying by 10 on both sides. The reason of multiplying with the 10 that the number of zeros or number of power of 10 indicate will be that number of digits which are repeating. If there is repeating one digit, then we will multiply with the 10 raised to power 1 on both sides. 10x. 10 multiplied by 0.444 and so on. If there are two digits which are repeating like this one, then we will multiply it with the 10 raised to power 2. It means we will multiply with the 100. That expression will becomes 2. Now we will subtract expression 1 from 2. 2 minus 1, or subtracting 1 from 2. What we will get? Left hand side will be subtracted from left hand side and right hand side will be subtracted from right hand side. Here is a mistake. That will becomes after multiplication 4.444 and so on. So we will subtract 4.444 and so on minus 0.444 and so on. Left hand side will become 9x and the right hand expression will be 4. Now that 9 which is multiplying with the x on the left hand side, it will be divided on the right hand side from 4. So this is the expression which is rational, and a rational expression of the given number 0.444. Now we will convert the second part of this question, which is 0.37 bar. This is a 2-digit repeating number. It means there are 2 digits which are repeating. Again we will suppose as x is equal to 0.37 bar. We can write it as 0.373737 and so on. 37 is the number which is repeating. The bar is on 37, so 373737 will be that number. Now as there are 2 repeating digits, so we will multiply it with the 10 raised to power 2, which is 100, multiplying by 100 on both sides. 100x and 100 into 0.373737 and so on. The right hand side will become 37.3737 and so on. After multiplying with the 100, it will indicate 37.3737 and so on. The left hand side is 100x. This is our first expression and this is our second. Subtracting 1 from 2, we get left hand side of 2 minus left hand side of 1, and right hand side of 2 minus right hand side of 1. It will become 37 and here is 99x. We will solve it on next page. (99x) equal to 37. The 99x is multiplying on the left side and it will be divided on the right side. So this is the rational expression of the second part. Now we'll move to the third part, which is also an 2-digit expression. 2 digits are repeating. Let x is equal to 0.21. It is not, let me clear that it is not a 2-digit expression. It is a non-terminating expression. The bar on 21 is indicating that in non-terminating expression there is a 21 which is repeating infinitesimally. Infinite times it is repeating. It means 0.21 0.21 and so on is repeating on infinity. This is our first expression. Multiplying it with the hundred on both sides. 0.21, 21, 21 and so on. It will become 21.2121 and so on, and here will be 100x. This is our expression. Second one, again we will subtract 1 from expression 2. What will become 100x minus x, and on the other side will be 21.2121 and so on minus 0.212121 and so on. The right hand side will be 100 and 21 and left hand side will be 99x. Now 99 is going to dividing on the other side, which will become the rational expression of the third part. Thanks for watching. Please like and subscribe my channel. Thank you.